Hey, hi. I'm back with another update on the game engine. It's been a little while. I haven't really had much to show because progress has been mostly lateral, not so much forward, which is I guess, a way of saying I haven't really done a whole lot. But I did implement a sort of shader type thing. I don't know if it's really how shaders would properly work, but it has interesting results. So I'm just gonna, I guess, demo that really quick. I've got my own like shader toy style setup here going on. So you can see I've got a couple things here already. The first thing you have to do in my implementation is tell it how to draw a fragment. So they're all tries in my implementation. So you have to tell it how to draw a fragment. We can do. I only have a few options right now. So the only thing we've got other than filling a solid try with a texture is wireframe. Oops. New try shaders, new add wireframe, and you can set the color on that, but there's really no reason to. It's there we go. Okay, you can see the background's white, so it's kind of hard to tell, but you can see the grayish line going through there. Boom, there you go. Wireframe. That's all there is to see there. Really thrilling. Now let's get into something more interesting. This will fill the screen with a big blue picture. And you can see it's blank 1280. That's 1280 by 1280. So that does have an effect on the shaders, and I'll show you that in a second as well. There we go. Solid blue. Whoop-de-doo. Okay. Now we add... Well, this one doesn't show at all because we're not using a picture with different colored pixels. But I can show you that too, I guess. Let's pull up the skybox. Yeah, there you go. So we got texture draws. That works just fine. And then we can throw in this wave texture shader, and this will just wiggle everything using sine waves vertically and horizontally based on those parameters there. So yeah, look at that. I know, really thrilling stuff here. Really thrilling stuff we're going through, but it's fun, and it's fun to mess around with. I'm gonna make one later here to show you how it works. Uh, yeah, there's all of that one. And then we also have this, which just completely overrides the color of the texture. But it does use UV coordinates. Now you can see a bit of a weird artifacting thing there because of multi-threading on the upscaler. But other than that, it's yeah, ignore that. Just ignore the fuzz. Ignore the fuzz. That. Don't worry about that. And then if we combine both of these, we can combine them. Amazing, right? Some of the shaders don't combine, some of them completely override, just because of how they work. These two work together because one of them shifts the UV coordinate, and then the other uses the UV coordinate in its calculation. So the wave shifts the UV coordinate that's handled by the shaders, and then the radial uses that UV coordinate. So once it's shifted, that effect remains. But with certain other things, that's not the case. We also have here. This is one that's more relative. Add hue skew. So this will just make. This is how you make things look like they're rainbow. You know. And let's have that go over 5 seconds. I'm sorry if you can hear the fan. This computer's a when it comes to cooling down. It likes to scream. I've had to re-record some of these because it's so loud. But yeah, there you go. Now it's all rainbow and wiggly. So, yay. I guess that's really all there is to show as far as how the shader thing works. But now I say we try and make one. I'm going to try and make a combination between these two. I want to make this hue skew where it shifted the picture through the rainbow like that, but also takes into account the radius. I think that would be interesting. So I'm just going to try and combine both of those really quickly. And I'm going to let you watch me struggle. Call it hue radial. Or maybe skew radial. Makes more sense because I'm skewing. Skew radial. That's going to implement shader. All right. Got to put the phone down. I was holding it away from the fan. Now I need both my hands. And you get to see how excellent of a programmer I am and how fast and good I am at doing everything. Okay, so we have the graphics profile. This has a bunch of the information we need, like the current time, the current brightness, which isn't something that is set at all yet in the code, and we're not going to be using that. It has the UV coordinates of the texture we're sampling, and for this pixel that this is going to be a pixel shader, so this is going to execute per pixel. Yeah, here, let me just go through. We've got the color of the pixel, we've got the time, we've got the texture itself, we've got the screen, we've got the aspect ratio, we've got the depth buffer, we've got the UV coordinates, we've got trichords. I don't think that's not right. Oh no, those are the barycentric coordinates. Okay. We have the actual vertices of the triangle in screen space. We have the whole vertex buffer available to us. Some of the stuff you wouldn't really use, but it's available. We've got all the render matrices. We've got the current transform of the model that we are drawing. Yeah, and there's the global light, and that's it. So all we're going to be doing is manipulating data. We're not going to be using any of those methods really, because the pixel draw method is going to get called right after this. So we need, first off, we need to determine a center point. So we're going to need like private x offset, y offset. So that's going to be our center point. And then we're going to take the distance from that center point on the texture and use that as a skew factor, basically. And then we're going to scale it by frequency. And period and stuff. We're going to have a period, probably. I'm just trying to think. Is that? And then we're going to set saturation and brightness as well. So that we can... Actually, no, we're not. We're not going to do that because we're going to be skewing. No, I mean, we can still do it. We can just scale it with... All right. We're going to take float HSB. First, let's get the color of the texture that we... wherever we're at. Color, RGB to HSB, texture buffer, get RGB. I'm going to pull some things up to make this easier. RGB, all right. I can't remember if this is in 0 to 1 or is this in pixels? I'm going to look at the other ones real quick. I'm going to cheat. Okay, it is. It is in pixels. UV 0, UV 1. And we'll just Am I stupid? Oh. What? Oh, this is dumb. Are you serious? Okay. What? I don't want to do it like that. I hate this programming language. All right, let's just do the distances. du equals uv0 by texture get width minus do I have it half the offset here? Oh no, that's so it's centered. Okay. Is that my body making those noises? What the hell? Weird. Okay. It's like a clicking noise. Is that this? Sorry, where was I? We've got our distance, and then that's all we. Okay, then we take actual proper distance since we're doing a radial. Do plus dd equals d. All right. We have our distance, and it's in normalized values, so it's a total of 1, and we're gonna take that and we're going to multiply it by our frequency so that we go through the whole spectrum faster based on our frequency, and then we're gonna multiply by the period, because when we set the period, we're just gonna set it to 1 over whatever's passed so that we can just multiply. And I think that's it. I just have to pull the RGB from the texture and set it as a color. C equals texture.getRGB. No, get RGB. Oh, wait. New color. Texture.getRGB. UV0. Okay. Get that. So we have the color, and then we want HSB. And it's going to be c.getRed, c.getGreen, c.getBlue, and then a null. Now we have the hue of the actual pixel of the texture, and we're going to skew it based on its distance around the spectrum. So literally all we have to do is this. I hate that O and 0 are right next to each other. I screw it up every single time. Frequency times times D. And then I need to put the time in there. Oh no, that's okay. So it's frequency times gfx dot t seconds minus d times period. And I'm not gonna do one where we set a full argument constructor right now. I'm just going to. Oh, and then I have to actually set the color again. Color. Okay. Color buffer. Wait. What if I? No, because that's an RGB. What if I do this? That should make it influenced by the previous, I think. So if I do then whatever the last one output instead. But I could also do it from the UVs. If it changes the UVs, it's see, this is where it becomes bad. Like either way, it could do something completely different. I'm gonna try it this way first. Pull the color, then set it to whatever color dot HSB to RGB. HSB. Oh, do you have to? Of course. I guess it makes more sense to do it that way. And we will do HSB 1 times saturation and HSB 2 brightness. Now we come up here, we'll set everything. X offset equals 0, Y offset equals 0, which can have it right in the center. Frequency equals 4, period equals, we want it to be 7 seconds, I don't know, yeah, sure. Saturation we'll just set to 1, we don't want to mess with it. And brightness we'll do the same. Okay, now, if this works, it should be as simple as adding a new shader. What do you, there we go. Okay, adding a new skew radial, and we cross our fingers. Angel, yeah, first try, yeah. Just like that, it was that easy. Just that easy. And just like that, I have my own shaders, and I can I can make them on the fly just like that. What did it take me, like 15 minutes? How long was I explaining, and when did I start? Whatever, I'll have to look it back. But yeah, it didn't take me that long. I hope. Who knows? It's pretty simple for it to take that long, actually. But yeah, that's it. As far as actual game stuff, I guess I can show you real quick, but there's not much to look at. In fact, it's ugly as sin. I do have another entry point here where I'm moving back to 2D, but it all still works in the 3D space. It's actually a plane projected into 3D space, viewed by a camera, and then onto that plane we draw a texture that is the 2D space. So that is what I'm working with now, and I'm gonna just work in 2D because it's easier, but I can still use all the same data because that math still works, but it's gonna make a lot of more complicated things easier, like telling where you're looking and what you're interacting with. It's gonna be a little easier than I think doing all that math in 3D. And you can see this texture looks like crap, so it really shows off that fuzz because of the it's really visible where there's a high contrast between horizontal pixels because of the threaded raster. See, when I'm going vertically, you don't see it as much. You see the occasional odd line, but you move to the right and boom, it's it's like someone's waving a magnet in front of the screen. But yeah, that's all there really is to look at. I just have this giant empty space to because I was just getting started on drawing tile spaces again, and I just had this giant space to make sure that I could make a big room and it wouldn't lag out if I went all the way to the edge, and turns out it doesn't, so great. So game engine, still no games, but lots of things. The shaders are cool. In fact, I think I can real quick put a funny one on here, maybe. This is here. Yeah, I can where am I? Okay, I'm using this one. I can add a silly little... I can add that one that we just did. Actually, I'm just gonna rip a couple from over here. I'm gonna rip this one. And I'm gonna rip this one. And I think we actually don't know if these work together yet or not, so this could be interesting. They do. Oh, dude, look at that. That's crazy. This is absurd. Now it kind of looks like Vampire Survivors because I can't tell what the fuck is going on. Woo! Oh, and it's ooh, it's because it's a screen space thing. When you move up, it's slow, and when you move down, it's fast. Wow, that that's nuts. Well, that's it. Shaders, game stuff. I thought it was really cool. Um, Hopefully that's something like what actual shaders are. I did look at shaderdroid.com, and that's what helped me figure out that I wasn't completely crazy when I was like, why don't I just pass the entire graphics profile to the to every single shader? And turns out that's kind of what you do. So, yay me, I know what I'm doing. I still don't know how to use a GPU. I still don't know how to do real parallel stuff, but how hard can it be, right? Like, how hard can it be? I don't know how to end this. That's why I keep rambling. I'm gonna go.